Hey everybody, this is Mr. Lowry here, and we got imaginary and complex numbers, which is kind of a orange colored worksheet here from Monday, September 13th. Before we get started on this video, I thought it would probably be a good idea to just talk about the most effective way to use these videos. Okay, so if you are just watching the entire video and just kind of riding along as I go, I don't think you're going to learn quite as much as if you stop the video from time to time to practice. Okay, so what that might look like is okay, I need some help getting started here. So you're going to turn on the video and you're going to watch number 1. And you're going to watch me do it. And you're going to be like, okay, I think I got the idea. Let me try number 2 or number 3 on my own. Right? So you might jump in and you try number 2 or number 3, and you try to follow the process that I showed you in number 1 and see if you can do it on your own. And let's say you get it wrong. Okay, cool. So now you can watch the video to number 2 or number 3 or whatever it happens to be, or check your answer, and figure out where you went wrong. Then you'll probably go back and try it again. Make sure you get the right answer, or try a new problem. But the idea here is to make sure that you can do this independently. Okay? So me giving you this video is what we call scaffolding. I talked to you guys about that in class before, and scaffolding is a way to get you to a level that you're not currently able to get to on your own. Okay? But by the time that we finish this worksheet, we should have some level of mastery with these types of problems. So if you are completely reliant on these videos to get through every single problem, then you're probably not learning all of what you need to learn, and I would recommend one of two things. I would recommend that either you come in and talk to me so we can talk about some strategies and figure out how to help you, or I would do what I recommended and try to be as independent as possible. Okay? Don't just follow along with the video just so you can get a bunch of problems.
We're still in the building. We have our tutor here today, here to help
Sorry,
you with
announcement.
math and science and English, so take advantage of that. Thank you.
Alright, sorry. I'm still in class here and they had an announcement. So anyway, try to become independent. That's the goal. The goal is for you to be able to do these independently. I know you will need some help sometimes. I know there are going to be things that get you stuck, but after you watch the video and after you practice, you should be independent. Okay? If you go through this entire worksheet and you watch the entire video and you can't do it on your own, what I would recommend is you just do the whole worksheet again. You get an extra copy and you try to do it on your own, and you keep practicing until you can do it independently. That's the idea. Doing it without my help, because on the tests, on the quizzes, you're going to have to do it on your own. All right, now with that being said, let's jump in here and take a look at some of these problems. All right, so number 1. What we're going to do here is we're going to factor the number inside the radical, which we call the radicand. Now you actually don't have to worry about the negative part right now. We're going to take care of that in a little bit. But I'm going to take 45 and I'm going to factor it, or break it down into its factors. So two numbers that multiply to give me 45 are 9 and 5. And 5's prime, meaning we can't divide it any further. Two numbers that multiply to 9 are 3 and 3, and those are both prime. So what we can see here is that inside 45 there is a 3 squared. Okay, so what I'm going to do is I'm going to rewrite this radical, and I'm going to write a 3 squared. You could also write a 9 there, because we know that 9 is 3 squared. And then we're going to multiply that by a 5. And then the negative part that we need to deal with, we're going to split off the negative part. We're going to call that a negative 1. And usually I put that in parentheses so it doesn't look like a subtract 1. So what I have altogether is a 3 times a 3, which is 9, times 5, which is 45, times negative 1, which is negative 45. And now that we have it all kind of broken up or factored, we can consider each one of these factors inside under its own square root symbol. So the square root of 3 squared is easy, that's 3. We know that that's the case because the square root symbol and the square are inverse operations, they undo each other. And so this is just a regular 3. The square root of 5 is actually irrational. It comes out as one of those ugly, non-repeating, non-terminating decimals. And since there's no other squared factors, there's no doubles of anything in 5, we can't actually simplify that any further. Okay, now the square root of negative 1, that's a little bit tricky. Okay, So we talked this in class today about imaginary numbers and what's called the imaginary unit. And it just so happened that we defined the square root of -1 to be I. Okay, so what you need to know for a lot of these, I would write this right at the top, is that the square root of -1 is equal to I. So that's like the smallest square, like negative square root we can take. I mean, we could have like the square root of -12, or the square root of -1,000, or the square root of a million, but 1 is kind of like a nice small number. So we pick the smallest possible negative square root, and then we call it I. So what we're doing here is we're using the imaginary unit, I, to help us simplify these radicals that are actually not real numbers. So the final answer here is we're going to have 3 times I times root 5. Now I just changed up the order a little bit of those 3 factors, and the reason why is I is a very narrow letter and it's easy to get lost. So if you write like the square root of 5 and then write the I at the end, it's kind of hard to tell whether the I is underneath the square root or not, and it's not supposed to be. So by convention, we just put the I in the middle, in between the rational number and the I guess I should say the real number, or yeah, the rational number and the irrational number. We put them in between there. So that's how we write it. Okay, now let's say that you're watching this video and you had no idea how to do number 1. Okay, well now you know how to do one of these, right? It starts off with a factor tree. You break it down into its factors, you simplify anything that can simplify, and then you're going to have a square root of a negative because these are all negative square roots. So what I would do now, as if you're using this video, which is totally fine, that's why it's there, is try to do the next one on your own. Try to do it without me. Try to become independent. And maybe you'll make a mistake, and maybe you won't. But if you do make a mistake, then you can come back and learn from that mistake. Okay, so the next one I'm going to do is number 2. But what I want you to do if you're watching this video is pause and try to do number 2 on your own. Are you trying number 2 on your own? Did you do it? Okay, if you didn't, you should try it. So now we should be coming back from something that you've tried already. So I'm going to take 192 and I'm going to prime factor it. Okay, I don't know what number is going to 192 off the top of my head except for maybe 2. So I'm going to just divide 192 by 2. I'm just going to use my calculator to do that. Okay, so that gives me a 96. Okay. Now 96, 2 also goes into that, so I'm just going to keep breaking it down until I see something that I recognize. So 96 divided by 2 is 48. Okay, now that one I know is 6 times 8, which is a 2 and a 3, and a 2 and a 4. Okay. And now I have a bunch of these tiny numbers. So let's see what we have. We have 1, 2, 3, 4, 5, 6 2's, and we also have a 3 in there. So this is the square root of 2 to the 6 times 3 times -1. Don't forget that -1. Okay. Now remember that the square root undoes powers of 2. So a better way to write this would actually probably be to write this with powers of 2, as many as possible. So 2 to the 6 is 2 squared times 2 squared times 2 squared. And then we have that 3. And then we have that -1. Okay, so what we're going to get out of here is actually 3 2's. A 2 from here, a 2 from here, and a 2 from here. So outside I have a 2 from here times 2 from that guy times 2 from that guy. Inside the square root, I still have a 3 multiplying a -1. So outside I have an 8. And then I'm going to split this guy up into square root of 3 and the square root of -1. This is irrational and can't be simplified any further. But this guy right here, we call I, the imaginary unit. So I have an 8, I have an I have a square root of 3, and there you go. Okay. Now there's actually another way to do this without prime factoring, and the way to do that is to look for the biggest squares possible, the biggest perfect square factor. Okay, let me show you what I mean by that. I would recommend that you make a list of the perfect squares. So like 1 squared is 1, and 2 squared is 4, and 3 squared is 9, and 4 squared is 16. And the more you do this, if you do this on every single homework assignment, you'll get really good at learning the perfect squares if you don't know them already. But the reason why we do this is if we can find a perfect square factor in the radicand, we can actually simplify a lot faster. So this is 121, 144, than we can with prime factoring. Okay, so let me show you what I mean by that. Going back to number 2. Okay, if there are any of these numbers, 1, 4, 9, 16, 25, 36, 49, 64, 81, if any of these numbers go into this number, that's something that's really easy to take the square root of. Okay, so check this out. What if I did 192 divided by 16. So 16 actually goes into that, which is kind of nice. So 16 is a perfect square, but it may not be the biggest thing. And in fact, I know it's not, because 4 goes into 12, so there's more perfect squares. So if I saw right off the bat, now this is kind of hard to see, but if you see that 64 goes into 192, 64 is the biggest perfect square that goes into 192. So another way to factor this would be able to say this is the square root of 64 times 3 times negative 1, which is actually what we have here, because 2 to the 6th is actually 64. If you can find those perfect square factors, we know that the square root of 64 is actually 8. So this is going to be 8 root 3i, which is exactly what we have. So prime factoring is a surefire way to get all of your perfect squares. But if you can recognize the perfect square factors of this number, you can actually get there a little bit faster. Okay, let me give you an example of that. Number 3. Now again, we just did number 2. If you needed help with number 2, that's okay. You should try to do number 3 on your own and see what you can come up with, and then come back and look at my work and kind of see if it matches and see if you have any questions. Okay, right now what I recognize is that 180 is a product of 36 and some other number. In other words, I know that 36 goes into 180. Okay, now that's just from like experience. So in order to see that, you have to be pretty good at multiplying. You have to know these perfect squares, and you have to be pretty good at like multiplying in your head. So you may not see that. That's okay. You don't have to, but if you do, it can make your life a little bit faster. So check this out. I'm going to rewrite this as the square root of 36 times 5 times negative 1. Okay? I just basically factored the biggest perfect square that goes into 180. Square root of 36 is 6. I have the square root of 5, because that doesn't come out, and the square root of negative 1 is I. And it's all done. Okay, so that might be like over your head, like, whoa, how did you do that? Well, again, it just comes from experience. It comes from being good at multiplying. It comes from being familiar with your perfect squares. So let's say you can't see that. Okay, well then our surefire method is prime factoring. So let's say 18 and 10, which is 9 and 2. 2 is prime. 9 is 3 and 3, which are both prime, and 10 is 5 and 2. And so we have everything now. So we have the square root of a 3 squared, and a 2 squared, and a 5, and a negative 1. So what comes out? A 3, because the square and the square root undo each other. A 2, again, the square and the square root undo each other. What's trapped is the 5 and the square root of negative 1. Since 3 times 2 is 6, this gives me 6. I have a square root of 5, and then the square root of negative 1, these are all getting multiplied, is an I. Okay, so either way, you can get there. Okay, now, if you're watching the video, you have seen 3 examples of how to do this now, 3 in a row, and talking about different methods and things. You should be pretty confident, pretty comfortable doing these, okay? So the next 4, I want you to try on your own. See what you can do. Okay, if you get stuck halfway through, or if you need to come back and check, you can go ahead and do that. But the idea, the goal here, is that by the time you've done this assignment, you can do a problem like this completely on your own without any help, because that's what it's going to look like when you take a test or a quiz. So we're shooting for mastery, and this is, we haven't mastered this yet, we're still practicing, right? But as we go through, you have to ask yourself, am I developing mastery? Do I actually understand what I'm doing? Okay, 5 and 7 you have the answers to, so I'm not going to do all these. I'm going to do 6 and 8 with you, okay? So you might want to ask yourself, do we know of any perfect square factors that go into 80? Well, 4 goes into 80. Is there anything bigger? 9 doesn't go in. I don't know if 16 goes in, but we can check. Okay, so 16 goes in. So what am I doing? I'm seeing which of these numbers go into the radicand. I was like, does 4 go in? Does 9 go in? Does 16 go in? Why do I want to do that? Because these are numbers that I can easily take the square root of. Okay? All right, so this is actually 16 times 5 times negative 1. So the square root is 16 times 5 times negative 1. Square root of 16 is 4. Square root of 5 is irrational, and I know that 5 can't be factored any further. And the square root of negative 1 is I. So I got 4, I got the I from this guy, and then I got the root 5. Okay? Or you could prime factor it, right? Break it down. 8 and 10. 2 and 5. 2 and 4. 4 is 2 and 2, right? And so we got 2 squared and 2 squared and 5, and you could do it that way. You're going to get a 2 times 2 on the outside, which is going to give you your 4, and you're good. Okay. Negative 338. It's a pretty big number. Let's think if anything can go into that. Any factors? Any of these. Can any of these numbers go in? I'm going to try a couple things. I'm going to try maybe 121. Looks like 121 might be able to go in there. I don't know. Let's find out. 338 divided by 121. Okay, that doesn't work out. That gives me a fraction. What about 338 divided by 144? Okay, nope, that doesn't work. So maybe those are too big. Let's try maybe 81. 338 divided by 81. Okay, nope. Maybe 49. Nope. This might just be an ugly one. Let's try 36. No, no such luck. Okay, now that took me a little bit, and there probably is a number. We'll find out what it is in a second. But since we couldn't figure out any perfect squares that go into it, let's just prime factor it, and then we'll get it for sure. So we're going to start, I'm just going to divide it by 2. I know it's even, so let's do that. Okay, 169. All right, see, that's what we missed. 13 squared is 169. Okay, so this is actually 13 and 13. All right, so the perfect square factor that goes into it is 13 times 13, or 169. So let's rewrite this. This is the square root of 13 squared. You could also write 169 in there, times 2, times negative 1. Square root of 13 squared is just 13. The square and the square root undo each other. I'm going to have a square root of 2, right? Because 2, we can't take a square root of 2 is irrational. We can't simplify it. And the square root of negative 1 is I. And we're going to put that right in the middle. Okay, there we go. So hopefully that helps. Okay, now again, the goal for you is to be independent. You should be able to do this on your own at this point. If not, keep practicing. Go back and do them again. If you're not independent yet, then you should go back and you should redo this assignment until you are independent. It's okay if you do the same ones over again, so just practice. Okay, we want to practice until we get it. 8 problems may not be enough practice for you. It's totally fine. All right, I'm going to stop the video there, but when I come back in the next video, we're going to talk about powers of I, and we're going to talk about doing some operations with I. This is like addition and subtraction stuff or some multiply stuff. Okay, so tune in on the next video for that.